Roach, exploring network programmability with Python and Yang. Please give her a hand.
So hi, everybody. Again, my name is Lisa Roach. I'm really excited to be here today to talk to you about how we can program and automate networks using Python and a modeling language called Yang. This talk is going to be relatively basic in terms of the networking concepts that we cover. So if you're a Python developer who's not super familiar with networking, don't worry about it. I'm really hoping to be able to speak to developers who are interested in getting involved in networking, but maybe don't have a ton of experience right now. So who am I? Previously, I was a software systems engineer at Cisco Systems, hence my background and interest in networking. Currently, I'm a production engineer at Facebook, actually doing back-end security. So this talk isn't going to be about what Facebook does, but if you're interested in what Facebook does for their networking, I definitely encourage you to go check out online. They've open sourced a ton of their documentation, so it may answer any questions you have. So what can we program? What do I mean by a networking device? Well, I'm not talking about the Linksys routers that are in your home office. I'm talking about the big switches and routers that you would find in your corporate data centers or your corporate backbone WANs. So those devices typically are configured using a CLI, manually line by line, which can be a little bit slow and challenging, especially once you start reaching scale. You can definitely manage a small number of devices using CLI pretty easily, but once you start growing from 10 devices to 100 devices or 100 devices to thousands of devices, you really have to start automating. So what kind of stuff do we want to automate? Well, a huge one is configuration management. If we're opening up a brand new data center with 1,000 switches, we realistically can't go through the CLI of every single one of those and apply a new configuration. What we want to do instead is have software that can run and apply that configuration on every single device at once. This can take a new data center turn-up time from weeks down to days. After our data center is up, we want to keep track of the health of our devices. Currently, this is done using SNMP, but some of the ways that I'm going to talk about today actually can gather more data more quickly than SNMP. This allows us to do automatic problem remediation or include monitoring and alarming systems for our IT workers. Now, these are two kind of basic must-haves, but if we truly can program a networking device, say if we have access to the routing tables on the device, we can start getting a little bit more interesting. We can start making custom protocols. So if you know your application so well, you know exactly what paths you want it to take in the network, you can actually start adding custom protocols instead of the protocols that come by default on box. And those custom protocols can be whatever is perfect for your application. So it's making your network a lot more efficient. There's more things I could go into, but these are just some of the more interesting examples that you can apply the concepts I'm going to talk about today to. So how can we program networking devices? There's currently really three ways to do it. The first way is with APIs. A lot of data center devices nowadays ship with an API on box. This is probably the easiest way to program a device, if I'm going to be honest. They usually work really well. There's documentation. Gotta love them. But APIs, if I have a brand new data center with 1,000 switches, all those switches probably don't have the same API in every single one of them. So I can't do a one script to apply my configuration to all my devices. And what I want to talk about today is ways we can program our entire network, not just a single box. So be aware that APIs are available, but I'm not really going to talk about them too much today. The second way is via SSH. Every networking device has SSH on it, I'm pretty sure. SSH, as long as you've got a library like Paramiko, like pexpect, like netmiko, you can send those CLI commands directly to the box over SSH. You can screen scrape the output, use regex. This is a common way that people have been doing for a long time, so I'm sure lots of people here are familiar with the joys of working with SSH on a networking device. The third way, of course, is what I'm going to be talking about, which is using Yang models and remote procedural calls. The way this talk is set up is I'm going to introduce a networking scenario where something is broken on a switch, and we will first use SSH to try to diagnose that problem and then fix it, and then we'll use Yang models and RPC to diagnose the problems and fix it. So you can compare and contrast the differences between the two techniques. So here's our scenario. We have switch A trying to talk to switch B. For some reason, switch A cannot send its packets to gigabit Ethernet 0000. We suspect somebody has fat-fingered the interface and has accidentally shut it down. So the interface is just not on. Super basic. How can we diagnose this without Yang or APIs? Well, this would be using SSH. Personally, I like using the Paramiko library, so that's what I'm doing here today. The first thing we want to do is connect to the box. Then I have a hard-coded CLI command. This is the exact CLI command I would be sending to the box if I was manually typing on the CLI. I screen scrape the output, and then I do a regex search to see if my gigabit Ethernet 000 is up. Now this script works, but it has a problem. And that problem is these hard-coded commands and the hard-coded output screen scrape. Now, I could take the interface out, make it a little bit more intelligent, have the interface be a variable, but taking out show interface and is up is a lot more complicated. If I have my 1,000 switches, and within those 1,000 switches, maybe I have 10 different operating systems. And if those 10 different operating systems don't expect the exact words show interface in that order, we have to rewrite this script or somehow program intelligence to sense what OS we're on and figure out what exact words we need to put there instead. So instead of show interface, maybe it's show IP interface or whatever it is. So this code is not repeatable without a large amount of work that we need to put into it for something that's so simple, and that's really frustrating. And I do want to point out networks are heavily mixed. It's maybe unheard of to actually have a network at scale that uses all one operating system or even all one vendor. Typically, networks have multiple vendors, multiple operating systems, so it's almost a guarantee I would have to be rewriting the script over and over again or developing some complicated framework to handle all of the differences that could happen. So this leads us to Yang. Yang stands for Yet Another Next Generation. It is a data modeling language used to describe configuration and state hierarchical data of networking devices. So to highlight a couple things in that sentence, it is a language. Some people kind of gloss over that when they hear about Yang. Yang itself is a language that builds models. It describes both configuration and operational state data. So we can see everything that we've configured on our device, as well as operational data like how many packets we're seeing, even really granular stuff like what's the temperature of my CPU right now. So you can do some really interesting telemetry with Yang operational models. And then finally, how can Yang help? Well, Yang gives us the opportunity to have a consistent model for configuring our networking devices and grabbing operational state data off those devices. So the really important word there is consistent. If every single operating system does not apply the same Yang model, then we have the same problem that we just saw with SSH. Yang doesn't really solve that problem inherently. Yang needs to be standardized. And we all know how fun standard making can be. So I really like this XKCD comic where the stick figure jokes, there's 14 standards, that's ridiculous. We should just make one standard that covers all use cases, and you end up with 15 standards. So Yang doesn't quite have 15, but I think I counted at least 5. One is the IETF, so the Internet Engineering Task Force, which actually published the Yang RFC. They're creating their own standard model, but it's been a little bit slow. Yang's been around for 7 years, and it hasn't quite covered a lot of use cases. So Google decided, hey, we're going to come along, we're going to speed this up. Google made their own standard called OpenConfig, which is open source to the community and has a really wide range of support. I would say it's probably the most well adopted of standards, so I'm going to be using OpenConfig in my talk. There's also IEEE standards, broadband standards, there's more standards on standards, but if I'm going to recommend a standard today, just use OpenConfig, and if we all use OpenConfig, then it'll all work out okay. There's also vendor-specific standards, but that makes sense. It's really impossible to create one standard that's going to cover every vendor's feature set ever. So we want to be able to allow vendors to have competitive differentiating features that they can add to Yang models. So you can actually extend OpenConfig Yang models with vendor-specific Yang models. So that way you can still use OpenConfig for everything that's standardized, but if you have something specific, you can extend it with a feature that you want. You can also choose to just use completely that vendor's model and not OpenConfig at all. So what does Yang look like? Yang is all about data hierarchy and defining exactly what order our data should be in and what type of data it should be. At the top of every Yang module is the name of the module. Today I'm interested in interfaces, and I want to use OpenConfig, so I'm using the OpenConfig interfaces module. The modules contain containers. In this case, we're interested in the container that contains my interfaces. Within there, I have a list of interfaces, and within the interface, I have data nodes, and in this case, that's just the name of my interface. So that's where we will actually see our data, will be the value of name. Now, these can get to be a little bit more complicated. You might be able to see that this container is grouped, and the other container config at the bottom is using a grouping. Now, this makes it really flexible, but it also makes Yang models nonlinear when you're trying to read them, which is not a lot of fun if I'm trying to figure out what should be nested, because you have to jump all over the model, and sometimes you even have to jump to different models to try to find the grouping that it's using. It can be a little frustrating, but there are tools to help. So there's a tool called PyYang, which includes, and it's a whole bunch of stuff you can do, but one of the things it includes is a tree functionality. So with tree, I can print out the whole Yang model, the whole hierarchy, including read-write data. Read-only data would be that operational data I was talking about, so just the state of the box, as well as metadata like types, etc. So how can we use Yang? Excuse me. If we picture data on a box as just being an unstructured blob, don't worry, you're not supposed to be able to read this slide. It's just a blob of data. If that's how boxes are without Yang, when we take Yang and we apply it to a box, we're structuring that data according to the way that the model has specified. So our data is now all laid out in the order and the types that the Yang model said it should be. Once we have our Yangified data, we want to have an RPC server running on our networking device. Yang itself was originally written for the netconf RPC server. So if you're reading the Yang RFC, you'll see tons of references to netconf-specific stuff. But nowadays, there's other RPC options available. There's gRPC, RESTconf, Apache Thrift, and I think that's it. and the netconf, that was the other one. So netconf uses a data encoding of XML. And you'll even find in the Yang RFC that there's a whole section dedicated just to how do I convert Yang models to XML data. And that conversion process is called Yin. So you can do Yang to Yin, kind of a cute little name. And the PyYang tool that I just showed you actually has a functionality to do that conversion for you automatically. But I don't really like working with XML. If I had to choose, I would much rather work with JSON data. So instead of using netconf, I wanted to use the gRPC server, which is a super fast RPC, and have it send me JSON data. So how can I use this gRPC server? Well, if I have my RPC client, all I need to do is do a GET request from my server. So I can get operational data or I can get configuration data. And it'll send me that back in my JSON format or my XML format, whatever I've requested. Now you can be done here, or if I want to make a change to my configuration, I can just sort of tweak that configuration that I got back from the box and make my update, send it back to the RPC server, and the RPC server handles the application of the new configuration all for me. So it takes the new configuration and applies it. So how do we map Yang to JSON? There's not a cute name like Yang to Yin, but there is an RFC 7951, almost as cute. And it tells you exactly how we can map Yang to JSON. And this is a completely lossless conversion, reversible, and pretty simple. First things first is we want to create our top-level key. That's a unique key because it's a combination of the module title as well as the first container that we're interested in. So our top-level key becomes OpenConfig interfaces interfaces. Now, if I didn't want to narrow down to a specific interface, I'm pretty much done here. I could set the value of this to be a bracket null, and then I would get all interfaces data, or technically all data that's located in that container interfaces. But I want to narrow it down. So I'm going to go into the next key, which is interface. Interface you'll see is a list. So you can see we go from brackets, we go to bracket brace instead of just straight to brace. Our leaf name is name. And then we want to fill in our data here. And that data is the gigabit Ethernet 0000, because that's the interface we're interested in. So this is essentially how we map Yang to JSON. And again, that PyYang tool will do this mapping for you, although it's a two-step process, because they make you first convert to XML, and then you convert to JSON from there. So let's fix our switch. Back to SSH. We've determined that our interface is off. How we fix this with SSH is we reconnect to the box. We invoke an interactive shell, because we're going to be sending a bunch of commands this time, not just one command. We wait for that shell to be ready to receive data. We send a bunch of hard-coded commands, and then we sleep to see if they work. Make sure that they all get committed. So we got to take a little breather while that all goes on in the background. So there's a few problems with this you may have picked out. One, I have to reconnect. I'd already reconnected once, but my connection was dropped after my command finished executing. Then I have this busy while loop that's not doing anything. It's just waiting for data to be ready to be sent into this shell. And that takes more time than I think you would think it might. It can take maybe up to a second, as you'll see in the timing as we go through. Then, of course, we have these hard-coded commands. Again, if I were to try to use this on a different box, these wouldn't work. I would have to program for a lot of tiny detailed changes in these commands. And then finally, the sleep. The sleep is an indicator of a couple of problems you experience with SSH. There are some operating systems, some servers that will send back to your Paramiko script that they have successfully executed, that they've successfully taken all your data. This operating system does not send that flag. So this is a problem in a couple ways. One, I didn't know it wasn't going to send that flag. So originally when I wrote this script, I just had an infinite loop that was waiting forever for a signal that never came. The only reason I found out that that wasn't working is because it just ran forever, and I had to trial and error my way to figuring out that this sleep is the only thing that I could get to work. I also had to trial and error how long the sleep takes. This sleep took 1 second, but I was doing a relatively simple command. If I was trying to configure something much more complicated, 1 second probably isn't enough time. So there's a lot of variability when writing these scripts, and there's usually not documentation out there that's going to say, this command will take 3 seconds to execute. So you kind of have to guess, which is not my favorite way of programming. So how do we do this the Yang way? Well, first we want to formulate a GET request to our RPC server, and we've pretty much done all the work for that already in our conversion from Yang to JSON. So we have this JSON output. If we put that into a Python variable, then I'm going to instantiate my gRPC client. This gRPC client is an open source client that you can find, the last slide of my presentation has links. So I instantiate my gRPC client and do a simple get config, and that's going to get me back all the data that was located within that container, specifically for the interface name Gigabit Ethernet 000. We can see that when we take that object, we loads it, we get a response object, and we dump it out, and we can see all this data we get. And I've cut off a ton of it. The amount of data you can get back from Yang oftentimes is even more data than what you would see in a show command, so you can get a lot of information out of this. One thing really important to highlight here, though, is that we need to make sure that our JSON dictionary stays ordered. As I've said before, Yang is really important with the order hierarchy of your data, and if I accidentally change the order of some of my keys and try to reapply it to the box, I would get an error saying this isn't matching Yang specifications. So you always need to be careful when you're using JSON to ensure you keep the order. Now, if we squint really hard, we can see within all this data that we got, we can find a configuration container that has an enabled false set. And so this is telling us that our box has turned off that interface. It's the same as a shutdown. So if we can change that to true, we're going to turn the interface back on. Manipulating the data is pretty simple. If you've ever manipulated a dictionary in Python, you already know how to do this. So we take our response object, drill down through the first couple of keys, openconfig interfaces, and then interface. We know interface gives us a list, but in our scenario, we only requested one interface, so there's only going to be one item in the list. We can safely grab just the first and only index that's available. This gets us a little bit closer to config enabled false. Now all we need to do is get from config to enabled and set it to true, which we can do really simply. If we do a dumps, we can see on our response object, the response object has been updated to enabled true. The only thing left to do is send this back to the RPC client and have it merge that configuration for us. This, again, is a simple process. We dump the object to updated config, and then call our merge config function, and this is going to handle any messiness on the back end all for us. This is all we need to do. We can get back an error, so if something has gone wrong, if you unordered your dictionary, then you would get an error request back. All the error messages are defined in the Yang RFC, so you can go look them up if you want. You would also have gotten an error back if you tried to request an interface that doesn't exist, so definitely look into the errors if you ever get confused. Just a quick check, we can do another GET request on our box to see if this applied, and we can see that enabled is indeed set to true. So this fixes our switch. In fact, both ways fixed our switch, but there were some issues that we saw with SSH. We saw that SSH is challenging to work with because it's difficult to write repeatable code. It requires a lot of complexity to be able to write an SSH script that will run on even 2 different OSs. The second thing, of course, is it's slow. We had a lot of timing issues, which I'll show you in the next slide, an actual timing breakdown. And then the third thing was it was unpredictable. I wasn't sure that I had to put a sleep there. I wasn't sure how long the sleep had to be. Some operating systems, it wouldn't be a sleep. It may be something different. So it's kind of hard to predict, and if anybody's worked with SSH, I'm sure you've had these frustrations before. So just a quick look at the timing, because I think it's kind of fun to see how drastic the difference actually is. That SSH screen scrape script took 2.8 real seconds to run, with a difference of almost 2.3 seconds between using a Yang model, which only took half a second. 2 seconds is pretty long for most small scripts of this size, but it's really long if we start scaling out to 1,000 devices, or more than 1,000 devices. This adds up really quickly, so the speed of Yang is a huge benefit. But there are drawbacks. So one of the drawbacks is it's not 100% stable. It's still kind of new-ish in the industry. People are still getting their feet wet. I looked up the openconfig models, and they seem to change about once a month. Not significant changes, but sometimes significant. So all Yang models can be found on GitHub. What I would recommend you do is just subscribe to the Yang models that you're working with, and then if a change occurs, you'll be aware that a change has happened. So just something to keep an eye out for. If your scripts suddenly start breaking, you probably updated your operating system and the Yang models were changed. It's not largely available yet. So it's coming out on a number of vendor devices, and when you go on the GitHub page for Yang, you'll see a bunch of different vendors are listed there with their particular models. Many major vendors have it, like Cisco, Arista, Juniper are all starting to support this, but it's not on all their boxes. I don't think it's on anyone's entire fleet of boxes, and it's maybe not guaranteed to ever be on every device. This is still something that's new, still something that the industry is trying to figure out if they want to adopt. So right now, you really have to check to see if your operating system supports Yang. The third one's a big one. Devices are blocking. Yang itself and RPC calls don't have anything that would make them blocking, but network devices usually do not allow more than one configuration change to be happening at the same time. So if I were to write a script that was automating my device and it was making a lot of changes on the back end, and I was an IT worker or a network operator trying to make a change on my box, I would never be able to. The script is going to be running so fast that I keep getting locked out of it because I just can't be faster than a computer. So if you're going to fully commit to automating your network, you really need to fully commit. You need to have a queuing system enabled so that way you can ensure that your scripts are always running one at a time, not overwriting each other, and not trying to run at the same time. So just something to be aware of. Last thing, the tooling and the documentation, it's still not fully there. PyYang is a great option to look at. I just saw today that PyYang has added support for PyYang bind, which will actually convert Yang models to Python classes. So there's cool stuff coming out, but it's all just coming out. It's all still pretty new. It's not fully fleshed out. So definitely something that hopefully in the next few years will be there. It'll be easier to get started on. Right now it's a little challenging. So that's it. At the end of my presentation, these slides will be uploaded. I have examples and links. The RFC is on there. The Yang page on GitHub that you want to go and check that your operating system supports this Yang model is on there. I've included a couple projects I've worked on that are like proof of concept applications that could show a little bit more exciting examples. The gRPC client I talked about is on there. And then finally, Napalm is on there. Napalm is a library that supports SSH as well as Yang. So if you're in a typical environment that has mixed support for Yang, I definitely encourage looking into Napalm where you can use SSH as well as Yang to write one script that will monitor your entire network or automate your entire network. So that's it. I'll be taking questions if anybody has any.
Hi, this is an awesome talk. Thank you.
Oh, thanks.
Explained everything really well. I was just wondering, so this looks like it works really well for routers and network devices like that, and I'm wondering if there are applications to use it for devices that are on a network, so if you wanted to monitor phones or printers, things like that.
Right now, there's no support for something like that. Yang is currently really only mapped to switches and routers. There's no reason it couldn't be in the future, but right now it's only working on networking devices.
Cool. Do you know of anything that does work for that sort of thing?
For monitoring phones and printers and stuff?
Yeah.
Not off the top of my head, unfortunately. Sorry.
No worries. That's awesome. Thanks.
Thanks.
Hey, I've got a quick question about the Yang models. Has there been any work done to create those models based on log files from devices, if the log files themselves are representative of a connection to the config T or show configuration?
I'm not 100% sure if I'm understanding your question entirely, but if we're using Yang, you could potentially not need log files, because if we're constantly pulling operational state data, that's kind of like the same as a log file, or at least that's...
But I see what you're saying, but in a situation where I don't have access to devices, but I want to work with object models from the devices where I have their files, does Yang make it compulsory to connect to a device, or would I be able to derive that object model from a flat file?
I don't think I've never seen a case where they're actually storing Yang data as a log on the device. So I don't think that and not that I have seen, I haven't, it may be somewhere, but as of right now, I only know of it as more of a pull model. I have to say, retrieve this data right now.
Okay.
I don't think it's saving the state anywhere.
All right, thanks.
Hey, so I just have a quick question. So in the aspects of where for example, Cisco has native SDKs for UCS or whatever, and using that with building custom Ansible modules or just natively using Python, is there benefits to using something like this versus that as far as a speed thing, or is there going to be a difference in that? I mean, obviously, I know not every company is making SDKs, but what's the benefit of them building this versus just natively making an SDK for their product, I guess, is my question.
Well, I guess maybe it's a matter of opinion, but if I were using an SDK that is Cisco specific and I only had Cisco devices, I think I would probably just use that SDK because hopefully it's better, or hopefully it's well documented and I can call TAC or whatever if something breaks. But since most networks would have a multitude of different vendors and different operating systems, that's where something like this becomes more powerful, because if I had just 2 vendors with 2 individual SDKs, I would still have to write 2 separate
Well, but not in
scripts.
the Ansible module. I guess that's my question.
Oh,
So if
yeah.
you already have that and you already either have Ansible modules or you're familiar enough to build the Ansible libraries yourself, if you already have the SDK,
Right.
I guess what's the benefit to something like this versus that, I guess? Because that's,
yeah.
that's the question. I'm just curious, like from a speed perspective, how that would work, I guess.
Yeah, I guess I can't speak to exactly speed differences between Ansible and between using RPCs. Plus, it would depend on what RPC you implement. Some RPCs are faster than others. But I can say using Ansible for configuration would work, but Ansible isn't typically used for any monitoring. So if I were to pick out a benefit, Yang has the whole operational state data, and that's kind of one of the positives that it has that Ansible doesn't have. In terms of applying a configuration, both would work.
Okay.
And I don't know in enough granularity about speed differences to say one is better than the other.
Okay, I was just curious. Thank you.
All right, I think that's it for time. Thank you, everybody.